So we are from Group 1, we will be presenting question 2014 June and December.
Terangkan secara ringkas operasi mesin larik berikut. Yang pertama, fencing. Operasi yang dilakukan pada mesin pelarik untuk menghasilkan permukaan rata di bahagian hujung atau membuat alur muka. Yang kedua, knurling. Operasi dilakukan pada pelarik untuk menghasilkan permukaan yang bergerigi atau menghasilkan bentuk kekerasan pada permukaan silinder.
Melarik. Operasi melarik adalah proses pemotongan bahan dengan cara bahan tersebut diputar di mesin pelarik dan dibentuk oleh mata alat pelarik. Hasil pemotongan bahan di mesin larik biasanya berbentuk silinder. Membahagi. Operasi membahagi adalah proses memotong benda kerja dengan menggunakan alat pemotong seperti bilah yang menyenam terus ke dalam benda kerja mengikut panjang tertentu. Ia biasanya digunakan untuk mengeluarkan hujung benda kerja yang telah siap daripada stok bar yang diapit dalam cap. Menggerudi. Operasi gerudi merupakan proses menebuk lubang pada benda kerja. Ianya menggerudi pada pusat setengah benda kerja. Mata alat gerudi tidak berputar seperti operasi gerudi mesin gerudi. Ini kerana benda kerja berputar pada spindle.
Explain the basic principles of X, Y and Z axis movement of milling machine using a label diagram. As you see the diagram, there is two types of milling machine. One is horizontal milling machine, X-axis long travel, Y-axis spindle motion and Z-axis travel cross travel. For vertical milling machine, X-axis long travel, Y-axis table cross travel and Z-axis spindle motion.
Explain briefly with aid of a diagram the mechanism of the 3-jaw chuck and the 4-jaw chuck to hold a workpiece. 3-jaw chuck is used to hold round the hexagonal work. It grabs the work quickly and within a few hundreds of millimeters or thousandths of an inch of accuracy. Because the 3 jaws move simultaneously when adjusted by the chuck wrench. This simultaneous motion is caused by a scroll plate into which all here jaws fit. 3 jaws chuck are made in various sizes from 1/8 until 16 inch in diameter. They are usually provided with 2 sets of jaws, one for outside chucking and the other for inside chucking. 4 jaw. Independent chuck has 4 jaws, each of which can be adjusted independently by a change wrench. They are used to help round, square, hexagonal and irregular shaped workpiece. The jaws can be reversed to hold work by the inside diameter. Based on the figure 2.1 and figure 2.2, name the lathe machine operation. For figure 2.1 is knurling operation. For figure 2.2, drilling operation.
Explain briefly with the aid of suitable diagram of these operations performed on milling machine. The first one is face milling. There are 2 types of methods of milling cut. For face milling, there is down milling, known as climb. Let's look at the procedure. The procedure is workpiece fed in the same direction of the cutter. Nextly, chips progressively thinner. Strong clamping is not required since the cutting force is directed downwards and keep the workpiece pressed on the table. Good surface finish, chips are thrown away during cutting, applicable for soft materials and finishing operations. Next method of milling cut is up milling for face milling. The procedure of up milling for face milling is workpiece fed in the opposite direction of the cutter. Chips are progressively thicker. Strong clamp is required since the cutting force is directed upwards and tends to the leaf workpiece. Poor surface finish since chips gets acclimated at the cutting zone, used for hard materials. Lastly, slab milling. For slab milling, there are two methods of milling cut. The first one is known as down milling. The procedure of down milling for slab milling is workpiece fed in the same direction of the cutter. Chips progressively thinner, strong clamping is not required since the cutting force is directed downwards and keep the workpiece pressed on the table. Good surface finish. Chips are thrown away during cutting. Applicable for soft materials and finishing operations. Up milling for slab milling. The procedure is workpiece fed in the opposite direction of the cutter. Chips are progressively thicker. Strong clamp is required since the cutting force is directed upwards, tends to the leaf workpiece. Poor surface finish since chips gets acclimated at the cutting zone. Use
Calculate the feed rate in mm or min for a 6-tooth helical carbide milling cutter with a diameter of 75 mm for machining a cast iron work plate CS90. Use a value of chip per tooth. First, we must know the point is. The point, we know the diameter of 75 mm, and then CS90 and CPT 0.25. Is 2 point. I don't know what to say, but we must know the point in question first. Okay, now we will go to the answer. First, we must find the mean, R mean. The formula we must know is CS multiplied 320 per D. Okay, CS, the question has give. CS is 90, so 90 multiplied 320 per D, the diameter of 75 mm. So the answer is 75. And then 90 multiplied 320, we must solve it and we will get 19200 per 75. And we solve it again, we will get 250 feet. Okay, and then we must find the feet in mean. The formula is N at CPT as the answer what we get. The firstly, okay, N is 6 multiplied CPT in the question is 0.25 multiplied the answer what we get. The first is 256, and we solve all of them, we will get the answer is 384 mm of mean.
Thank you.